Okay, let's get started. Welcome back from fall break. I hope you had a relaxing fall break after the horror, I guess that was midterm too. Not really, but so the conference I went to is great. Fortunately, I didn't get any questions, so I didn't have to answer anything difficult, but it was interesting. So it was a conference in Duluth, Minnesota about like mathematics research type of things. And what I presented was more on the computational side than what the mathematics side was, but it was still interesting to see what other people were working on. Okay, so obviously I wasn't here for Friday's midterm, so I'm just gonna quickly go over this. I haven't seen the test, so I don't know what actually happened. So I did hear that the TAs handed out extra pieces of paper. So remember for the test, if you looked on the back side of the programming sheets, there was extra space for each of the programming questions, which you were allowed to use. So yeah, so I'm going to guess that the other tests are going to be in the exact same format as this because I like this better than the first one. So you'll have extra space, and I might actually put a whole extra sheet just in case for that reason. Okay, so just going to quickly go over this. So the first question, if you have any questions about the midterm itself, just in general. We'll see. Well, I haven't seen the test, so I have no idea. So I don't know what will actually happen. So the plus plus operator just adds one to a variable, not a literal, because that's just something hardwired into the program, like an actual value, and a constant you can't change. And the other two are obviously not right. While loop is different from a do while because while tests at the top, do while tests at the bottom. So A is the right answer. Sentinel marks the end of a list of values. It does not have to be negative, but it can be. But it just doesn't have to be. This one is, so the first two are not even things in the language, so those can't be right. C gets out of the loop entirely, so it can't be C. Remember, it's going to the next iteration, not just getting out of the loop entirely. D is the right answer here. Continue from that point, immediately goes up to the top of the loop and proceeds with the next iteration. E is just something that you can do on each of the iterations to do an update. So you don't have to do that. And it's only for for loops anyway. But continue always goes to the next iteration of any loop at all. When is any function executed other than main? Whenever it's called. So that one should be pretty simple. How many arguments can a function have? How many can it have? 0 to many, yeah. It can have any number. Variables outside of functions are global variables. This one we covered pretty extensively, modular programming, breaking up a function into multiple ones. What return type does a constructor have? None. It has no return type, not even void. So the first four are not true, so it's E. And what does the destructor do? It's C. For this one, destroys a program, what does that even mean? Removes unneeded objects. So that's what a destructor is supposed to do, but it doesn't have to do that, okay? But you could, if you wanted to be evil, for example, have your destructor not free up the necessary memory and just have a leak of memory somewhere. So you could just avoid the responsibility of a destructor here. C, it definitely is automatically called when the object is destroyed. And opposite of a constructor, what does that even mean? Does it destroy the objects? It's not really clear what this means. So it's C here. Any questions on the multiple choice? So these should have been pretty straightforward. So there was an error that I just fixed for the first one, which is I put these equals zeros on. So here it's just implementing the clamp function. If it's in the right range, then return the value n. If n is smaller than the low side, then just return low. Then otherwise, it's higher than the high side, so return high. The equals zeros here are necessary because I say that they have a default value of 0, so I was testing about default values. Of course, there are many other ways that you could have implemented this. Okay, max, I say that you have to take 2 parameters by reference, so you have to put the ampersand there. Returns the maximum, and you have to create a prototype as well as the function. So the prototype's at the top, and then the implementation's here. If x is larger than y, return x, otherwise return y. Pretty simple. And there's not really much room here. There's another way you can do it, but this is the usual way to do it. Min is almost exactly the same, except now I return y in this case, and otherwise return x, when y is at least as large as x. Sorted, you didn't have to use the other functions, the min-max functions, but you could if you wanted to. And that's why the hint is here. Does not return anything, so the return type is void. Good. So here, I just compute whatever the maximum is. I don't know which of x and y is the maximum. I don't actually care. I just care about the values. So here I just compute the max, whatever it is, compute the min, whatever it is, and then just print the min followed by the max. Pretty simple. Prod prime. Anyone see an error with this? So this does not actually do prod prime. I just realized it. Oh, no, sorry. Prod prime's down here. Is prime is right here. So there's no error. That was my fault. So you didn't have to make an is prime function here, but it's just helpful if you, because we're calling it twice here. So I just make a is prime function, and then I just check, well, all possible values of p between 2 and smaller than x, all possible values of q. If p is prime and q is prime and the multiplication is right, then x is a product of primes. And then if we've tried all possibilities of p and q and none of them work, it can't be a product of primes. And so therefore, we're all set. So this function is actually extremely, extremely important to secure communication. So if you want to like talk to your bank, for example, over the internet, so what you do is you have your own prime value. This is not actually what happens, but you have your own prime, and they have their own prime. But if they or you send your primes over, then an attacker can look and see, oh, this is the prime that's being sent. So what actually happens is you compute some encryption on your prime, then send it over. The attacker can't see the prime, and the bank can't either. Then they take your encryption, encrypt their own prime as well, and then send it back. And then once you have both of them, you can actually decrypt it on your end because you know the decryption for your prime. And so therefore, when you send it the other one back, then both parties, the bank and you, both know both of the primes. And so therefore, now once you know the primes, you do the multiplication to get this product of primes, then send that number over. The attacker can see the product of primes, but in order to be able to figure out what are the two factors, that is a very computationally hard thing to do. And so this function is pretty much underlying all secure communication of the internet. So that's one of the reasons why I put it on your test. Okay. This one is num called. I wanted you to use static here. And I say you can't use global variables. You had to use static in this case. So when I set equal to 0 here, that's only on the first time the function is called. So then I increment and then return. Doubler is just for doing a concatenation of the string. So we talked about concatenation using the plus operator on strings. So this one was pretty simple. You just take a string, return x plus x, or you could set it to a variable and return that. Other ways you can do it, and then just return by string. Pow prime, this one I actually use a lot in my research. So I use powers of primes all the time. So this is just very similar. You just check all possible values that could be assigned to the base for P, and then we just look and say, we're going to just look for the correct value of A, and then just recheck it at the end. Of course, there are other ways you can do it. You could take the 8th root of X and see if it's an integer. Very similar to the way that assignment 4 is. You can do it in many different ways. And then this one, I wanted you to use bit shifts. So you just do the max and min as before. You initially set the maximum into the result. So the lower 32 bits are where the max is. And then you OR in, moving the min bits all the way over 32 bits. And then it returns both of them simultaneously. So, but you could interpret this in different ways. I'll just see what you guys write, and then I'll make a reasonable assumption on what you did. Any questions on question 2? Okay, so question 3 was pretty straightforward as well. So we have an include guard up here. We need IOStream for the innovate function. For the private variables, we need the name, the GPA, the num credits. Here for the version number, this could be a double or a string. It doesn't actually really matter what this is. But I do say 1.0 somewhere. Yeah, 1.0, so that should indicate a double, but you could make that a string if you wanted to. Then here's the default constructor. I just set the variables accordingly as specified in the directions. I make the destructor here, no problem. Here's the overloaded constructor where I take the 3 parameters here. Then I do the check on the GPA and then set the internal variables according to what was passed in here. I have a getter for the name. Then, of course, the most important function, the innovate function, which sets the variables as specified and then has the infinite loop again as specified. And then for update GPA, this is actually how ASU, or anyone really, updates your GPA when grades come in. So what they calculate is the number of credits you've already earned times the GPA on those credits. So that gives you the number of points associated with what you've earned so far. Then the number of points of this new course that's being added is the GPA of the course you just got and the number of credits for the course you just took. So that's the number of points. And then divided by the new number of credits that you've just had. So in addition to the course that you just took. So the number of credits you took before as well as the new course. And then now, of course, we have to update the number of credits. Once we've seen this course, we need to add the number of credits we just took onto the number of credits now we have taken. And then the NDIF at the end for the include card. Any questions on question 3 or the midterm in general? So hopefully I'll grade these by Friday, but I'll see what actually happens. Yeah. Okay, so any questions otherwise? So what is due tonight? Assignment 4. Any questions on assignment 4? So hopefully everyone mostly got that. But any questions on assignment? Yeah.
If you turn it in, like it doesn't return all the values, do you dock it hard on that?
What do you mean return all the values?
Return all the values for
Yeah, so you print the 5 values as well as the exponent. All you need to do is print them. You don't return anything.
what?
You print the counterexample. Or are you talking about part 2? I'm not sure which. Are you talking about part 1?
Part 1,
Yeah. So all you have to do is print the counterexample and then return 0 once you've found the counterexample. And that's all you need to do. Well, in addition to putting stuff in the comments saying how you actually did it. But that's all you need to do in terms of the program. Other questions about assignment 4? Any questions about assignment 5? Okay, so last time I said we were going to finish all the stuff on objects, so I'm just going to breeze through these last bit of slides. The stuff on structs, as I've said before, structs are equivalent to classes in some sense. So everything that we've learned about classes applies to structs as well. So I'm not going to ask anything, I can't really ask anything specific about structs. Okay, so just a few slides about object-oriented stuff. So the analysis part of this is when you're given requirements, you need to be able to understand and figure out, okay, I should make an object for this and an object for this, and then maybe this object is going to be a member of this object, and then maybe we're going to have some kind of hierarchy between these objects. So that's what you need to be able to think about. So like for if you're making a set of programs or classes for, say, ASU, you need to know, for example, a student for ASU, a professor for ASU, an instructor for ASU, an actual class for ASU. So here you would say, well, a class is going to contain student objects as well as one instructor object or maybe a professor object. It depends on the actual class. Then maybe the student object is going to have a name, an ID, and you need to be able to think about what types of things are going to be part of what objects. And then how do these classes relate to each other? So in looking at individual classes and objects, you need to think about what things are relevant to this object. So like for an ASU student, the name and ID come to mind. Those things are tied to a student or a GPA, for instance. But other things are like user interface stuff, physical objects, data. So we're going to start arrays today, and so the data part will make more sense today. The attributes, that's basically what I said, is just how do the functions relate these member variables together. So like if you have an ASU student and you have a list of courses that the student has taken, then how does that relate to the GPA member variable of the student? That sort of thing. And then, so here there are relationships between objects. So the one that we have seen is basically ownership. So like, for example, remember the string class. So for an ASU student, it has a name, or he, she has a name. And then like for a double, he, she has a GPA. But there are other ones like uses a and is a that we haven't really talked about. Is a is actually really interesting and we will cover it. But so the idea behind that, which is inheritance, is you want to minimize the code redundancy between classes. So for example, maybe we can have a class that is devoted to all faculty at ASU. So of course they have like a name and an ID, and then maybe like a job title. But then when you want to make a professor or an instructor, that is a type of faculty, okay? So like an instructor is a faculty member. A professor is a faculty member. And so you don't want to have to rewrite all of that code related to the name and the ID because that's shared among all faculty members. So, but we'll talk about inheritance later in the semester. And of course, if we're making class, we have to know what's the class actually used for. So like for a student at ASU, what things would you actually use students for? But mainly to populate a class object, well, a course object. So a course has a bunch of students, so you need to make student objects to populate a course object. And then you need to also figure out, well, what things should this class know? Should the ASU student class know, for example, other professors' names? Maybe in some certain circumstances you might, and maybe not in others. So that's another thing you may want to think about when you're making classes. So object reuse is don't reinvent the wheel, essentially. Just have reusable components and not have to redo things that you already did. Yeah. And then a program that uses classes and objects is called object-based because you're making objects and manipulating objects. And this is just putting a term to what we've been doing so far. So a program that has more objects than procedural code is more object-oriented. But of course, as we've seen, there's advantages and disadvantages of using object-oriented programs versus procedural ones. Mainly, object-oriented programs are more on the side of just working with the objects and not really doing all the computations that we have been doing in the procedural way. But the procedural way, you have to actually manage all the data yourself versus just putting it into the object and letting the object do all the work for you. So there's just an advantage-disadvantage type of thing here. But any questions on objects before we move on to the really cool part, which is arrays? Okay, so let's move on to arrays. So excited for this. So giddy for arrays. So up until now, we have been basically trying to figure out, okay, we introduced this new concept. Do we get any additional power that we didn't before? So for if and else statements, we were able to get different programs than we did before because we didn't have a way of conditionally executing some code and not others. Does the switch statement, for example, get us more power than if and else? Does switch give us anything else? You can tell by my tone, the voice, that it isn't. So why does switch not get us any more power than if and else? Right, so it's just basically equivalent to a bunch of if-else statements and if-else chain. For loops in general, that does get us more power than if and else, right? Because now we can say, oh, we can repeat this code as many times as we want, potentially a number of times given to us by the user, and we can't anticipate that in advance. So loops do get us more power than we did before. But objects don't get us any more power than what we did before, or functions for that matter, because we could have just managed all that data ourselves. If we just had a few objects here, we could, in principle, just write all the code that's equivalent to making those objects and managing all that data, etc. But now, arrays give us a lot more power. I would say even more than all the other if and else and for loops combined. So arrays are intensely powerful. Pretty much, this is the end of the line in terms of how much more power our programs can get. So arrays are very powerful. So what's an array? So if we wanted to make a whole bunch of student objects, for example, say 100,000 at ASU, we could, in principle, do that. But the thing is, as ASU starts to get more and more students, now we have to update our program as necessary to add all of the code for that. And managing 100,000 objects by ourselves sounds like a really horrible thing to do. Whereas arrays, what we do here is say, oh, we're going to package all of those objects together and put it into one object, okay? So if I wanted to manage 5 test scores, for example, so what I do here is I make an array called tests, and there are going to be 5 integers in this array. So this array is basically equivalent to having 5 different integers. So here I say, this is just to say how large the array is. I don't have to do this first line. But here I say, I'm going to make 5 integers packaged up into this one object called an array. So the square brackets here indicates that it's an array. Okay, so here, when I declare this thing, there are going to be 5 arrays packaged together. We don't really concern ourselves necessarily for how the 5 integers are stored in memory, but if you wanted to know, they're stored consecutively in memory. So, for example, if an integer is 32 bits, just as an example, then if I declare 5 integers here, that's going to be 160 consecutive bits of memory. So 32, then 32, then 32, 32, 32. And for some reason, there's a very good reason, but for some reason, the way that we access the individual integers in this array, it starts out at 0. So, okay, so I'll show you how that works. So let's make our, let's fix this, namespace std, and then let's make our array here. So let's make int tests of 5. So here I'm saying that this tests object has 5 integers in it. If I instead said string here, what would this object correspond to? 5 strings, right. So the type I put out here is how many of the corresponding type is going to be in this array. But I'm going to use int here. So the way that we access, say, the first integer in this array is, well, I could, if I wanted to, set and get from this array just by using the square operator. So if I wanted to set the first integer in, oh, go ahead.
Sorry, so when you set it to strings, the strings are treated as arrays of characters?
Yes. Yes, but we're not accessing it in that way, but if you wanted to think about it that way, yes. It is an array and of array. And we'll talk about 2D and ND arrays once we get there. But if I wanted to change the first integer to, say, 42, because 42 is the answer to life, universe, and everything. So then what I do is I say, this array at the beginning has all the integers default initialized to 0. So as you might expect. But I could say tests of 0 equals 42. So here I'm setting 42 to be the first integer in tests. If I wanted to set it to be the second integer in tests, what would I have to do differently? I would do 1 instead. So if I wanted to access the ith integer in here, I would set to the i-1th index. Okay, so the integer right in here is called the index. Okay, so here I'm setting to index 1, whereas before I was setting to index 0. But of course I can say, well, tests of 2 is equal to 100. Actually, we could do this. We could say tests of 0 plus 100, for example. So here, the square operator is both accessing and setting into this array at the same time. So over here, I'm getting the value from tests of 0, then adding 100, then setting into index 2 of the array. So since we only have 5, I can do this easily. So by printing these out, I could say this. Don't you love copy and paste? I love copy and paste. So here, there isn't a way that I can just print all of the elements in the array simultaneously, unfortunately. But here, since it's only 5, I can just print as necessary. So if I print this, look at what happens. Ooh, that's interesting. 1, 2, yeah, that's fine. So I'm not sure why that's not initialized to 0, but that's really interesting. But what happens here, ignore that for a second. So here I set 42 to be the first element of the array, which we see here. I didn't set index 1 anywhere, so it should be default initialized to 0, and it is. We looked up 42, added 100, and set to index 2. So the third element is 142. We didn't set tests of 3, but for some reason, I'm not sure what happened here. Maybe if we run again, it'll give us... Don't you love programming?
No, not really.
What's his name? Anyone know who Raymond Hettinger is? So how many of you have programmed in Python? So there's a conference called PyCon, and Raymond Hettinger is like one of the core developers of Python, and he gave a presentation at PyCon once, and he said he was live coding in Emacs, if you happen to know what that is. But basically live coding, and he gave this amazing quote, which was, never ever do live coding at presentations. It's extremely dangerous. So it's definitely the case here. If I do this, it'll work just fine. So that's actually an example of where you can't just assume that something is default initialized to 0. I thought it was, but I guess not. But any questions on how arrays work in general, where we just set and get? Yeah.
So for the example, as the pie size, you said it was bad. What would, like, you initialize pie size at 5 and test pie size?
Ooh, good question. So that would be equivalent to me doing this. So if I wanted to print tests of 5 here, what do you think would happen? So I'm printing index 5, not the 5th element, index 5. So what do you think would happen? I actually think it'll be a compile error. Oh, nope. So what do you think happened here? Why did it even succeed? Yeah. So this is actually one of the good and bad things about C++. So the good side of it is I can access any memory, most memory locations that I want to. So here, the 5th index is not in here. So remember, there are 5 elements in here. It starts at index 0, 1, 2, 3, and 4. So the last index in this array is 4. But I'm accessing index 5 here. So what happens here is something called undefined behavior. So I'm accessing something that's not defined by the C++ language of what it'll do. The program may crash. It may, in this case, print whatever data was there. So we have to be a little bit careful in trying to access the data in our arrays carefully so that we only access the things that are defined in the array. Whereas here, you can actually do something that was not expected. Okay, so great question. Other question? Yeah. Yeah, so here, since I declared the type of the array to be int, I can't, for example, say hello here because I'm assigning a string to basically an integer. Each of the array elements is an integer, so I can't do the setting like that. But if I did string instead, then that would work just fine. So I can have this be of any type that I like. If I made an ASU student class, then I can make ASU student here. It works exactly the same. I wonder what happens in this case. I know what happened here. Anyone know what happened? Can anyone guess? So when I print a string, how does it know? Because remember, strings can be of any size, right? So how does the string know to stop printing? Null terminator, right? So if I have this right here, is there necessarily a null terminator there? No. So what'll happen is it keeps printing until it finds the null terminator. Can anyone see how this could be used for bad purposes? So what could happen is if you have a program that logs in users, for example, and you control the index from like the login panel, then what could happen is if you set the index to be too far away from the array, then what'll happen is it'll keep printing data over and over until it finds a null terminator. So this is actually a source of security bugs where you access things that are outside of the structure. Fortunately, languages like Java and Python and other things, if you try to do something like this, the program will throw what is called an exception. And we'll talk about exceptions later, which will if you don't do anything, will immediately stop the program, as you might want it to in this case. So, but if I print test of 4 here, it shouldn't actually cause any issue, and it doesn't. Yeah. Yes. I don't think so. Well, you could set a global variable into something in an array, but the issue is that an array by itself is a contiguous block of memory, whereas a global variable is initialized to a piece of memory that's not in the same place. Remember, it's in a different address space than the local variables are. So you can't put it directly into it, but you can set to some other variable in there. That would be completely fine. Yeah, of course. Yeah, so it works exactly the same way as a normal integer or any type for that matter, but now it's just we have multiple of them at the same time. Other questions about arrays? Yeah.
You overloaded, say you had string test and int tests. Would that work?
No. So you have to, it works the same way as for normal types. So if I redeclare a variable, then it won't let me. So if I do something like this, then it'll complain, hey, you redefined this thing. Yeah. Other questions? Yeah. Well, here it's a string, so a decimal in quotes would be fine because that's a string, but I can't put a double, for instance, into a string because those things aren't compatible. If I had a long array, for example, and I put an integer in, that would work fine. So it works exactly the same way. It's just now we have a whole bunch of variables at the same time wrapped up into one thing. Other questions? Good questions, guys. Please keep doing that throughout your undergrad. Your professors will thank you. So you ask great questions. Some things that I don't even know. So this is just some terminology. The type is at the front, as all variables we've seen have. Test is the name of the thing. Square brackets just says how many of this type are living in test. So here, I size was 5, so we have 5 integers there. And then the size of the array, although we won't really talk about this that much, is just the number of bytes that we allocate. So here, since int was 4 bytes, 32 bits, it's just the number of elements in the thing times the number of bytes or bits that was needed. Okay? Some examples of this. So you can have any type. You can have int or double. Doesn't actually matter. And then the way we access array elements is, again, through the square bracket operator. And then we remember that the indices start at 0 and go all the way up. If I have n elements in this array, so maybe 100, for example, but n in general, what is the index of the last element in the array? If I wanted to print, if I had 100 elements in this array, what is the last index? Is it 100 or is it? It's 99. Why is it 99? Start at 0. Right, exactly. So yeah, so just keep that in mind. If you want to print the last thing in an array, look up the size minus 1 index of that array. So here, if there are 5 things in here, tests of 4 sets the last element in tests. And if we want to print things, we just or cin it, we can do it in exactly the same way because tests of 0 just looks up the integer at index 0. It's still treated as an integer. So it's as if we're declaring 5 integers and you're now setting the first one. But it's just, it works exactly the same way as you have been using variables before. Okay. So the thing in the square brackets, in addition to being called the index, is also called the subscript. So I could be accessing the 3rd index or the 3rd subscript, means exactly the same thing. But of course, I could be accessing things in terms of a variable. So I don't have to put a specific integer in there as the index. I could put any variable in it. So how could I use this to help? Oops. Yes, I do want to undo. I don't know what. See the importance of testing your software? All right, so let's go back to this. So maybe if we wanted to do something like this, like print all of the elements in the array, I could do something like this, but what is a better way? Anyone have an idea? You use a for loop, right? Because do I know how many times I'm gonna loop through this array? Like loop through trying to print these elements? Well, I could have a loop that says, oh, I'm gonna print one element, then the next iteration is gonna print the next element, next iteration will print the third element, and so on. Well, do I know how many integers are in this array? Yeah, 5. So I could have a loop that says, well, I'm gonna make a loop that runs exactly 5 times. Okay, so I'm gonna make a loop that does this. So I start at 0 and go through I less than 5, so I'm not including 5 here. So this is a good way to say, oh, I'm going to loop through this thing exactly I times. So, but the other great thing about this loop is it's looking at the indices of the array at the exact same time. So the first iteration of the loop, I is equal to 0. Good. And what is the first index of an array? 0. So if I wanted to print the ith index of this array, I just cout tests of I. So if I do cout tests of I, that'll do exactly what we want. But here I have a comma separator, so I'm going to copy and paste that in here. And then now we can compact our expression much more easily. Although I'm not sure why this is an issue, but this will do exactly the right thing, even though I can't run it for some odd reason. Yeah, I'm not sure why it's weird. See the importance of testing your software? Configuration is incorrect. I'll figure out what happened. But this is supposed to do exactly what we expect. Let's go to cpp.sh. See the importance of testing your software? I think it's something because I'm not necessarily connected. But this should do... Oh, I have a better way. I can run it locally. So I'm going to save this to my desktop array example. And then I'm going to compile it directly. So I'm going to go to my desktop, and I'm going to G++, which is the compiler, what do I call it? Array example. And then how do I run this thing? ./a.out. So if you wanted to compile it directly, this would be the way to do it. And we get the same weird error here, and I want to figure out why that is. But we do print the 5 integers that are there. But any questions on why this works? So if I change this to 100, I have to update this in 2 places, but I can extend this as far as I like to. So I don't have to do that cumbersome cout expression. The size of an array, you mean? Or the number of elements in an array? Number of elements, there isn't a way with arrays directly. So there's something called vector, which is far better for arrays, which you can get the size of it, and it does exactly the same thing. But we haven't talked about vector yet. But any questions on how to actually do that? But so this is how you access the elements exactly the same way. But there's a much better way. So what if I was just doing something wrong by accident, or I'm malicious, I do it on purpose, and I put less than or equal to 5 here? Could that cause a security issue? Yeah. So there's actually a better way, which is called the range-based for loop, okay? So what this is do I really need to know the indices for our program over here? Let me go back to it. Do I need to know the indices of this thing to print this out? But do I use the index number itself, or am I just accessing the array elements? If I'm doing something with the index, I may want to know what the index is. But all I'm doing here is I'm just printing the elements of the array. So I don't actually need the index for our usage. So here's what we do instead. So we say, well, if we want to print every test in the test array, we just say int test. So I'm making a new variable here called test, which is the individual element of the array, in, which is the colon here, test. And so I do this instead. So here I say, well, for every single integer in this test array, then I just print that value and I'm done. I don't even need to know what the index is. So if I do the compile and run like we did before, it does exactly, well, other than the last integer, it does exactly the same thing. Okay? Can anyone see how to do this even better? What if I wanted to change this to be a string? What would I have to do for the other part? Change it to string. So now I have a mismatch here that the types are not going to be the same. What if I use long here? Or something like that? Then it could implicitly convert to int and not do exactly what I want. If I put string here, it wouldn't even work. It wouldn't even compile. But there's something that could happen here. Is there something I can do about this int to make my life easier? Auto, exactly. So if I use auto here, it gets the type right every single time. So if I change this back to int and compile, oh, okay, yeah. So here, if you look here, it says this is a C++11 feature. If you look at this compiler and if you looked at the version of it, it doesn't by default use C++11. So the way to get C++11 here is you specify the standard that you are going to be using, and in this case, C++11. So the way you do that here is you say flag for the minus sign, std equals C++11. So if I do that, then there's no warning here. And then I print, and then it does. But it does exactly what we. It should do exactly what we want. Okay. So you can actually see, well, I guess things are not default initialized to 0 in arrays. So for most memory, you can actually see most things are initialized to 0, but sometimes they're not. So yeah, so leftover values. Can anyone see an even better way to do this? I still have a minute and a half. Is there a better way we can do this? Am I modifying test along the way? I can put const here and say, oh, I'm not modifying test here, I'm just printing it. Can anyone see even a better way upon this to do it? What if I had this big honkin' ASU student object and I'm looping over these ASU student objects? What does this do? It copies the value of the ASU student over to test, for whatever, if it's called test. Is there a better way I can avoid having to do this unnecessary copy?
Reference.
Do a reference. So if I put a reference here, I'm just accessing the value. I don't care about having an independent copy. So this thing I use all the time for a const auto ref on the range-based for loop. Okay? Yeah, so I would highly recommend doing this because now you can avoid having these off by one issues. So you just loop over every element in there. You don't manage the index, and so you can't get it wrong. Sometimes you need the index, sometimes you don't. Most of the time you don't. But any questions about this? Yeah.
So is there a good way to get rid of that last comma on the end of the final?
Yes, there's a way, but we haven't learned about that function. So there's a function which allows you to put a separator in between every element of the array and then just dump all the data to C out. But this is the easier way to do it. Other questions? I'll see you on Friday.